Welcome everyone. Thanks for coming along tonight, attending the PIANC seminar here. PR presenting just into the microphone here so we can get things cast online. Yeah, welcome and look forward to some interesting topics around challenging marine infrastructure. First, thanks to SLR for hosting us here. Thanks to Emma, May, and Zoe somewhere out there for pulling this together with us, and thanks to McConnell Dowell for helping out with some of the catering as well. HSE, just get through those important things. Green running man, if something happens, follow him out the door. Any first aid, Emma's got a first aid kit, certificate and kit. Toilets just behind the kitchen there on the left for most of you blokes. I'm assuming the woman's is a little bit further down. But yeah, great to see so many of you here tonight. Large audience, and it's great to be able to bring the Port Engineers Forum along and get that intertwined with PIANC. Little plug about PIANC if you don't know about it, because we've got a few people here who aren't members. Do jump on board if you're interested. Permanent International Association of National Navigational Congresses. It's an old organisation, 1885 was formed. Continue to be the leading partner around the globe around navigation and shipping and waterborne infrastructure. Conferences are a big thing, but the working group papers and guidance notes and being involved in those is the core function of it, and publishing those documents. So yeah, that's the guts of it, but it's good organisation to be a part of. Great for networking, great for learning about marine infrastructure and what you can do better. And I find it really useful as a port operator, seeing what's out there, seeing how others are doing things, seeing what you can bring back to your organisation. Without any more further ado, we'll get into some presentations. Just format for the night, a couple of presentations, and then we've got some food back there, a little bit of an intermission. But yeah, four really good presentations tonight. And Greg over there is ready, primed, ready to go. Number one, priming. Do you want another one? Get him going. So yeah, Greg Kroef from Heron Construction. He is here to talk about the Henderson to Otahuhu transmission tower, marine foundations. Yeah, I haven't seen too much about him, but he said it was a tricky one. Well, he said it looks tricky. He said it was a breeze. So
we haven't finished it yet. So.
Oh, right, there you go. But yeah, thanks, Greg. So yeah, about 15 minutes, and then about 5 for some Qs.
Yep.
Q&A at the end. So yeah, thanks, Greg.
Righto. Yeah, as Marty mentioned, Greg Kroef, Managing Director of Heron Construction. So what I'm going to talk about is the replacement of some foundations, and I'm just going to guess it might be that one or not. Oh, turn it on.
Turn it on. Oh yeah, keep going.
You should have been using it.
Yeah.
Okay. Replacement of the 220 kVA lines for towers 79 through to 73 at Te Atatu on Whao River. So this started back in 2020. Transpower approached Heron Construction to see whether we could help them out with initially some remedial works on the towers. First thing we did, we sent the servo vessel, one of our smaller ones, obviously, up the river. If we look, I don't know whether there's a pointer. No, anyway. So that's for those that don't know where it is. It's the on the northwestern motorway at between Te Atatu and Rosebank, and there's the Watermanor Hub is just on the just disappearing out of the screen. And the towers are based basically in the mangrove intertidal zone. Because of the environment that we're in, we needed to look at some specialist equipment. We had the amphibious machines, some punts that could work at high tide, not so good at low tide. And the first tower that was immediate that needed repairing was Tower 79. I actually attended the risk assessment, and one of the true risks that they had, and this was pre-Cyclone Gabriel, with that tower was the foundation was so weak the tower could collapse and the lines could come down on the northwestern motorway. So one of the actions that we took with the equipment was to put in screw piles on either side of the tower plinths. We X-rayed through where we could find where the reinforcing steel was, and we basically did a belts and braces approach with steel frames to the plinths, and then connected them into screw piles. So you can see it's literally a band-aid. These are the screw piles that we put in, and then basically that gave Tower 79 particularly, and then that gave us a bit of breathing room that we could, working together with consultants, come up with a design to basically replace the foundations. More photos of the plinths and the screw piles. Installing the screw piles. Very close proximity to the towers. They were transmitting power all the time. So stage 2 was to replace the foundations on Tower 79, and that happened August 23 to August 24 to April 24. Then 78, then 76, and we've just started on 74, and we've got 73 to go. That's a finished product, and that was Tower 79 straight opposite the boat club. We needed to procure some, more specialised equipment, and one of those pieces of kit was a amphibious tracks for a 50-ton excavator, which at this time was one of the bigger ones that had been brought into the country. So that's a high cubed 40-foot container, and basically there were 2 containers. Each one of those had tracks, and the other had the rest of the equipment. There's the machine being assembled. That's a 100-ton crawler sitting beside it, so it gives you a bit of an idea on size. And being launched at the boat ramp. Also procured a KR50 drill rig that would go on that excavator. Obviously, we couldn't get any cranes or traditional drill rigs out there, along with a Fambo hammer and a Movax driving head for the excavator, and a couple of cranes. So again, marine equipment. We basically, our base was on the barge up by the tower. That's where the boys' smoker shed was. Everything was there, and everything came to and from that. Concrete was delivered by I bought a concrete truck. Took the bowl off it. We mounted it on a flat rack and put a hydraulic power pack on it, and then we lifted that onto the barge, skipped the concrete from the truck into the bowl, and that barge went up the river again, pushed by the workboat, still agitating the concrete as it went, and then from that bowl we put it into a concrete pump and pumped it into the piles. Tower that we just finished on, we ended up needing a second bowl because 2 reasons. One, it was further away from the site, and the tide gave us, because we're further away up the river, the tide gave us a shorter window to work in, so we had to get that concrete in there quicker. So we ended up with so I ended up buying another concrete truck. So to make access, when these towers were put in, there was originally a channel of sort that was dredged. So the consent allowed us to maintain that channel. So we converted the long reach, the smaller, back into a long reach, and we would dredge the channel, which would allow us to get the barge up there and all concrete supplies. Get the guys up there at high tide. At low tide, when the guys couldn't get there, I think we purchased about 400 plastic pallets, and that's a designated line that Transpower use, or route that Transpower used for their maintenance team to do the maintenance on so so that it didn't get too uncomfortable. Yeah, they'd lay down plastic pallets and go from there. What we did find was when the amphibious machines around the towers, when we first got there, they were fine. Like with everything, the more you move it, disturb it, the softer it gets, and you end up getting very stuck. So that's a 50-ton machine. You remember in the earlier shots, the tracks would have been above my head. So that's how deep that was. We did get it out, but what was decided, and from that time on, that was Tower 79, and we've done that on every subsequent tower. We've mudcreted around the perimeter, or around the whole site actually. So we ended up driving the sheet poles through the mudcrete, and you can see that. Well, there's the guys walking around, and the machines stay on top rather than going in. The added advantage for that is the maintenance crew from Transpower also love that idea, because that mudcrete will be there forever and a day, and they're not wailing around in mud either. The sheet poles were put in so that they were just above high tide. Sheet pole, copper dam around the outside, keeps the water out, keeps everything nice and dry. We never actually had to pump anything out. We did originally have thoughts that we might need to pump them out. On the left-hand side was our first shape, if you like, of the cofferdam around the plinths, and then on the subsequent towers, we realised if we did a cross shape, we had better access and could get closer to with the machines and get closer to where the piles went. Again, piles. Putting in the sheet piles and mud. This is Tower 79, so the sheet piles are almost done. Mudcreting's done. This is one of the other towers that gives you an idea of the high tide access for the team, and those machines basically stayed on site all the time. You can see around the base of the foundations there of the legs, we've got temporary works up. So this is almost at a finished stage. So those temporary frames are holding up that tower. At a point of time, we had the tower was held by 4 temporary frames. There were no concrete existing plinths at all. There's a good shot of the piles. So they were 610s. We had to splice them because we couldn't drive them in one piece because of the head height. So they were 12 metre length. Well, they were 12 metre lengths, and then splice on top of that to get them through. We couldn't pitch the 18s in one go, again because of headroom. So each plinth, each footing has 4 piles in the corner, and there's we're testing the welds, checking for position. Again, very close proximity to the pylon. We had set up geofencing around the pylon with the systems in the excavator, and the crane, so the operators knew exactly how close they were and it would alarm off. Driving those piles through, and then drilling them out, and then driving again if we had to. Poured underwater, so they were. We drilled out through the bottom to do a plug, and flooded the pile, and then Tremi poured all of the piles, setting up for the box foundation. Yep, delivering concrete by barge. That's for those that are aware. That one was actually left over from the Waiheke Marina, because we ended up having to get with the protesters. They shut Firth Concrete Plant down on Waiheke when we were doing that, so we had to get concrete from Halsey Street and put it on that barge and push it all the way from Auckland to Waiheke to get our concrete. So it came in handy on another job. So there's the box footing. So we'd pour the outer perimeter, Again, 2 concrete pumps and 2 concrete bowls in the pumps, and we're pouring that one. A little bit out of order for some reason. So this is the temporary works that got put up around the on the box footing once that was in place. The final steel was welded in place. All the main work was done in our shop in Papakura, but then it was decided that the best way of doing it was doing it in place and getting it bang on. And there's an example of the concrete and the reinforcing steel that was all broken out by hand, and some of it you literally with a small jackhammer could just push it in, and it was like putting a knife into butter. So there wasn't too much left. All the time we were monitoring, surveying the legs to make sure nothing was moving. So far, touch wood, we haven't had any issues. But there's the temporary works and the box. All the steel in the base is galvanised. Reed bars going in, tying into the reinforcing cage. And then the plinths get poured. Yep, finished pouring there, bolted down, and dry packed up, and then torqued down. Again, monitoring very closely while we're doing this process with the surveyor, making sure nothing's moving and it stays in the same position. Now, don't ask me which ones these are, but those are so basically three towers that we've completed, and it's just the 4th one just done, and now we've got 1 more to go. And demobilising, another lesson learned that we had from. We found that when the excavators, and this is the big excavator, the 50-tonner, when it's out on site for so long, there's so much mud gets incorporated and mudcrete gets incorporated into the tracks, which is very difficult to clean out, and actually puts on weight. And when you come back, it became very unstable. So we decided we would fabricate up some side pontoons to give us extra stability for this. Once we get to the next site, or we're coming back to the boat ramp, then they come off and it just operates as normal. And that's it. And that's a quick overview on how to change the piles on the foundations on high tension power lines, power pylons, while they're still in action. And not one of them's fallen over yet.
Bolts in them.
Yeah, we don't undo the we make sure we've got bolts on before we unbolt. So yeah. Any questions?
Yeah. Questions from the floor? Come on, someone's got one. Yeah.
Is there any movement at all?
No.
In terms of the lines, where were you measuring?
At the base, at the footing. Yeah.
Also, good innovations there. How was the contract left? Was it D&D or?
It started off as a cost plus on doing the screw piles. It was literally a cold call. We'd never done any work for Transpower. I believe what we're being told by Transpower is they saw one of our jackups working in Wellington, and thought, oh, we'll give these guys a try and see whether they've got any ideas on how to do this. And then basically, yeah, it's a negotiated contract after that. So we put in our rates and have an argument with the QS and agree on a number and get out there and do it. So.
One more question. Anyone else? Anything online? No. Nothing online. All right. Oh, thanks, Greg. Thanks for sharing there, mate. Great,
Thank you.
technical project. Sure, a lot of the risk assessments and lots of contagious things went into that. But so yeah, thanks, Greg. But next one, we have Brendon Barnett. Where is he? Brendon Barnett? Oh, right here. And Dave Perbey, Brendon's from McConnell Dowell and David Perbey is from Royal Haskoning, and they are going to talk about the Queen Salute International Wharf Upgrade in Nuku'alofa, Tonga. So, yeah.
We're going to need to plug in.
Oh, it didn't work?
Oh,
You
right.
should have told me that.
Double laptop, righto. No, well below. That's all right. I'll give you that. Quick, is this your mic?
Yeah, imagine, the
Yeah.
mic, and that's,
Yeah,
I don't know, that's would be connected because
Oh,
it's a
yeah,
different
won't.
laptop.
No, she's
maybe.
just pulled it outside. She's just put it underneath for you.
Yeah.
There you go.
Thank you.
Let's crack on.
All right. Yeah, great to be along and have an opportunity to talk about the Queen Salute International Wharf upgrade in Tonga. It's a project that personally I love talking about. I spent 2 years living in Tonga for the delivery of this project. Recently just returned at the end of last year after being there since end of 22. So yeah, it'll be great to go through some of this. And David Perbey, our lead designer and engineer to contracts, also here to talk. He'll introduce himself and then we'll get into some of the technical stuff.
Thanks very much. I didn't have the luck to live in Tonga for 2 years, but I guess I started in 2019 doing the initial scoping and go all the way to detailed design until site supervision. So I'll try to share a few of my insight on that. So the site is to the left-hand side, to the green line. So that's a typical Pacific project, I guess. You got a reef and they reclaim on top of the reef. That's not, yeah. On top of the reef. So you can see the wharf 1 and 2, which are the two international wharf. So they were built right on the edge of the reef to go straight into the deep water. So it's about 13 meters. Then right at the bottom, you got wharf 3 and 4. That's domestic cargo. That's not in use anymore because they built a bit further down the coastline a new domestic terminal. What's important to know about this site is the only international port in Tonga. So everything comes through that gateway. So it's about 90% of their imports. They got fish, but that's about it. So they need a lot of food and product, etc. Obviously, it's very important when you got a disaster as well. Make sure you got a bit of a lifeline. And the wharf number 1 in 2021 was condemned. So I got the luck or the bad luck, I don't know. It depends, to go underneath that wharf, and straight away I was horrified, and to the point that I have to go to the port authorities. I'm very, very sorry. Tonight you're not using this wharf. This is not good. So yeah, they were a bit shocked, and when they saw the picture, they understood straight away. They never went underneath the wharf for 40 years. Don't ask me why, but the good news for them out of that is really trigger a whole upgrade project which had to be financed, and then end up to be co-financed by DFAT for 70 million USD. So from being condemned one wharf, they gain a whole site, which is a pretty good outcome. And as well, yeah, quite important. Next week, we're going to Tonga because this is the end of the ceremony. So October 2025, we start in 2022, just as back of COVID. So 3 years project delivery is actually really good in Tonga, usually 6 years plus. And considering that we had COVID at the beginning, we had a cyclone, we got tsunami, we had the war in Ukraine, etc. We've got quite a lot of things against us. So it was a really good performance to deliver in 3 years. So that's just some really rough pictures here to try to explain a bit. That was the state of the port. Yeah, that's the underside of the wharf 1, the one we condemned, and actually that's still look good. That was in 2018. 2021, by the time you went in demolishing it, that was even worse. So that's not cable, that's reinforcement poking out of the concrete. Then you got the lighting, you couldn't see anything. It was a lot of dark spots, and unfortunately a worker lost his life in 2018 because of that, because they couldn't see where they were. Drainage, if you've been in Tonga, it rained a lot during the wet season. So if you don't have a good drainage, you end up having a swimming pool and your container in the middle of it, which is pretty bad when you got reefer containers, you've got cable going through it, so it's very dangerous stuff. And mooring, you can't really see there, but you see later, it was built in the 60s, so the wharf were sized for much smaller vessel compared to the one you got in Pacific now. So obviously all the ship overhang, etc. So the mooring, the bollard were on the side, etc. So that's the scope of work. So you can see to the left-hand side, that was the port before the project, and to the right is after. So you can see what I was talking about. The ship are overhanging quite significantly. They are not, they couldn't operate safely. So we end up extending the wharf number 2, putting some dolphin, berthing, and mooring dolphin to make sure the ship are secure so you can offload. The domestic wharf, which I talk about at the bottom, they were very heavily used. So it was a lot of concrete repair, massive hole through the ship hull, you got LWC, etc. So a lot of repair there. The container terminal, you can see the containers are stacked absolutely everywhere. So obviously we have to, we took the opportunity to reorganize everything. We've done all the pavers, etc. Put some reefer gantry because they used to access with ladders, the reefers, etc. So yeah, a lot of services were derelict as well. The substation was very bad. It was hit by containers before. You got trenches with water on it. I wouldn't go anywhere near the substation. So we took the opportunity to completely demolish it, make a brand new substation raised above water level because the site gets flooded by tsunami and cyclone, and make sure we got a substation with a genset with 4 days worth of supply. Because when the power goes out after a cyclone, you still got reefers. You need to make sure you can power them during that time. Firefighting, that's probably a funny one as well. It was absolutely no firefighting. They had one fire truck, it didn't start. So yeah, we just have to say we got the truck. So we went through all that and built a brand new pump station, all the rectification, etc. And yeah, now there is a firefighting system. And the master already talked about it. It was no lighting really. One of the key things to do, it was the sequencing, because that's the only international port, so we couldn't close the whole site for 3 years. People need to live for 3 years. So we split it up in 2 phases. So you can see to the right, that's the phase number 1 behind wharf 1, and to the left is phase number 2 behind the wharf 2. We started with wharf number 1 because I explained it was actually damaged, so it makes sense to start fixing up this one first. And we took the opportunity to upgrade all the eastern side because it was very low in terms of ground level. So we raised all the sides and we put a proper sea defense for protection, which was good for us because for the remainder of the 2 years, we had protection against flooding and cyclone. Another thing as well, this phase 1 was a bit of a lesson learned because it's where you got the outlet of the stormwater. So that was the deepest. So there was a lot of challenges at the beginning with groundwater and etc. So it makes the phase 2 very efficient because, yeah.
Very challenging putting the services in there. Yeah. You can have 3 6-inch pumps running in a trench and not even move it.
And yeah, we put a capping beam on the middle so we can do a whole pavers for the phase 1. So we could hand over phase 1 first while we're working on the phase 2. And one of the key things was the power. So obviously we couldn't just switch off the power. We provided a temporary power to the phase 1, temporary refer point. And then when the substation was got in commission, we switched over, and that was quite a bit of an event because we were a bit concerned that we might kill the whole power on the island because the network is not really up to speed, let's say, but it went pretty successfully. That's maybe a bit more interesting in terms of technical now. So it's plenty of things to talk about, but I picked this one, the piling, because it's not very common, I guess, to go and do piling into limestone. So how this pile work is you got your structure, the effort go through the pile head, reinforced concrete pile head, sheet connectors go to the steel tubes, go all the way to seabed, and then again you got a rock socket, reinforced rock socket, so you transfer the force to the rock socket, and that's socket work in friction in the limestone. We picked that one because we got a lot of uplift to do with waves, cyclone, and tsunami again. It was a lot of debate at the beginning. Should we go for driven pile, a bit more standard, because we didn't have to use fly drill, etc., which is double on link, take more time, etc. But when we actually installed the temporary pile, it was very clear it was the right option, because we ended up driving 10 meters and having hardly any friction on it. So yeah, that was a bit of debate, but the right solution at the end. Another debate we had is about the borehole. So when you core limestone, the recovery of borehole sometimes is a bit misleading. You end up with some part of it look like gravel. It's really because limestone is very brittle, so with the coring just break into pieces. And there's a lot of argument: is it a cavity filled up with gravel, or is just the borehole breaking into parts? So to get around that, we've done some downhole investigation, and it turns out no cavity at all. We just got these little walks, small voids, which is actually perfect for the rock socket to have good interlocking. We've done as well some pile testing, so that's a picture down there. Several containers, 200 tons worth of load on top of it to measure the deflection, and we had 8 millimeters from memory. And as soon as you remove the loads, it came back to 0. So we were all in a stick zone, so we're pretty happy about that. And then it was a lot of argument as well about why not having a pile, fully concreted pile from rock socket to the pile head. It turned out to be actually quite a good decision to have two separate elements, because unlike New Zealand or Australia, the supply of concrete in Tonga is a bit unreliable. And when you start to pour concrete, you can't stop in the middle and wait a few hours. You have to, when you pour, you have to finish it. So
very quick drying times.
Yeah. So yeah, that worked perfectly. We have no delay on the pile, any issues. So, and the last one before I go back to you, Brendon, rock bags. So Tonga is limestone. It's quite difficult to find very heavy boulders. It's 21, the density is not really heavy. And when you go and mine the limestone, they just break, 1 to 2 meters maximum, and you can't really carry them on a truck. So you're quite limited with the size of the rock you got, and there's a lot of evidence around the island that those rocks are not heavy enough for the cyclone waves you're talking about. So we end up using some rock bags, which go up to 8 tons. So a lot more stable to cyclone waves. And it's actually exactly the same local material inside of it, just smaller pieces, 300 to 500. And we did some testing on that, and actually was used here in Littleton for scarring protection quite successfully. So we had some testing, and yeah, we're quite happy about it. And another double opportunity with this type of rock bags is we demolish wharf one, so we had a lot of concrete laying around. So rather than disposing it, we remove the reinforcement and reuse the broken concrete pieces into the bags, saving buying materials, etc., or disposing concrete. And the installation was pretty quick using a mobile crane. So
cool.
That's it for me.
All right. I'm going to talk a bit about some of the delivery challenges in an environment like this, and some of the solutions we came up with to get through those. But so yeah, concrete, something that David touched on. So we had to make all our own concrete up there. So there were some local concrete suppliers, but they couldn't make the concrete to the standard that we needed to. We needed 40 MPa plus in some of our structural mixes and our trims. So we set up our own batching plant, shipped it up there. We went around to all the local quarries, collected material, find what we could, got it tested to check if it can do the job. Sent a lot of that out to New Zealand for testing, and then we worked on some mix designs, and including structural and tremmy. Tremmy kept me awake a lot of nights before tile tours, because it's very difficult to get coral aggregate flowing. It's quite rough. It's very dry. It has high absorption, and it's like throwing sponges into your concrete chuck. The amount of water that it takes. So water consumption is huge. We use local workforce, so we had about 180 people working on the project overall. Of that, 140 were local and trained up to the point that we had our concrete batching and testing team. There were 13 working in there, led by a Tongan who was Tongan born, had worked in New Zealand and then returned for the job. He worked with Becca for years and years and things like that, so he knew it inside out. And we trained up a lot of locals. We also had a concrete testing lab, cylinders in the bar, compressive strength testing machine, and we never had any failed concrete go in. We were testing to the same standards that you would in New Zealand, Australia, and our 40 MPa mix could hit 60 MPa on a good day. But yeah, dry times were really rapid. That was the biggest thing. Luckily, we were 1 minute away from the site. And we also did the field testing with our local engineers. Precasting. Oh, this isn't the updated version. I'm going to have to remember them. So we precast on site as well for all our underground services. Around about 60 pits, stormwater, firewater, and electrical pits. Around about 30 panels for big oil separator chambers and chambers, and over 100 mass concrete seawall units that we precast. And same thing, completely local workforce trained up by one of our expat precast supervisors, and they were doing all their steel fixing, formwork, and precasting in the yard themselves, and we'll carry them over to the next project as well, because some great skills learned there and retained. Training. So yeah, obviously another thing is the local workforce had never really built anything on this scale, and this was a huge job. So we needed to make sure that they were trained up just as to the same level that anyone would be in New Zealand or Australia. So we did all the vocational stuff, working at heights and fine space. We used a lot of local providers when we could for things as well, and also we did some social issues training using the Ministry of Health there, as well as some local groups that work in the island to spread that. But yeah, overall 3,000 hours worth of training into the local workforce, and like I say, we've retained them all as much as we can to carry over to the next project. Sustainability. So in that environment, waste management is a huge issue. There's one landfill, it's overflowing, it's a terrible state. We didn't want to contribute to that, so where we could, we looked for opportunities. So we sent 126 tonnes of steel to New Zealand. As David mentioned, the recycled concrete going into the rock bags, that was by design. We even shipped out our waste oil and managed to divert 85% from landfill. And here's some images. So as you can imagine, sending scrap steel to New Zealand, a very manual task. So that's, guys with gas axes cutting it up, packing it into sea containers. We did that in downtime when we had it. And yeah, managed to get a lot of that out to New Zealand for scrapping. Here's the concrete, waste concrete being broken up for going into the rock bags, oil pods going out to New Zealand. The entire port was paved. I'm going to say 1.7 million pavers or more across the port. So we had a lot of shrink wrap. That all came out from Australia, these pavers. A lot of shrink wrap to get rid of. We shipped all that back to New Zealand as well. And then also just a heap of old dead gear on the wharf. This is a crane mast that we had to cut up. The wharf was kind of, when we turned up, it was as is, where is. We had to clear the site before we could start building. So all the old forklifts, all the old containers, all the old cranes needed to be chopped up, bits and pieces like that. So that's some of the broader stuff that we did around construction as well. And I think, and this is the hero shot taken just about a week ago, finished wharf in the context of Nuku'alofa, which is the capital of Tonga, and we're just about gearing up to build a bridge across that lagoon starting next month as well. So it's great place to work, some challenging projects, but went really well, and we got some carry on off the back. So, yeah, so that's us. Any questions? Oh,
yeah.
yeah, there's a
Yeah,
thing.
spit into this so that the people at home get it.
It's a really sleek microphone. Are you going back to do the bridge? Are you going to move back to Tonga? No, that's not the question. So you showed a couple of pictures of the wharf, before you started, and talked about the fact that there was no fighting service over on the port, and then there's pictures of the construction teams working over there with full PPE on and all the training that you talk about doing. You talk a little bit about how you manage that interface between the clients, potentially lapsadaisical approach to health and safety, and then the NZ Australian standard that you were working to.
Yeah, we essentially we had to fence ourselves off. So that was part of the. It also worked from an operational perspective, but we put a fence line right down the middle. We had our own access points and everything like that. So it was our rules inside the fence, their rules outside the fence, and our guys getting them on board, up to speed, all of that kind of stuff. I thought that was going to be one of our biggest challenges. It actually ended up being in the reverse. The guys, I guess they'd never worked for a company before that actually cared about their safety, their well-being, all of that kind of stuff. So you give them the gear and they'll wear that to church. So it was, it was, the uptake was easy on the PPE. And then there was also all the training behind it, helping understand why we have all those requirements and things. But yeah, very stark contrast between the port operating over the fence, clambering around, climbing on things, riding on cranes. The amount of times I saw people go off the top of the containers into the water, off the ships and stuff like that, and you got our guys on the other side. So yeah, there were challenges there, but didn't struggle too much with the buy-in actually. Yeah.
Got some questions online.
Oh.
Did you have to provide anchoring piles, attaching the piles to the surrounding soil layers for uplifting forces?
I'll give that one to David.
Yeah, that's a rock socket. So the rock socket, by definition, was anchored into the limestone.
What did the detail look like for that?
For the rock socket?
Yeah.
So that's so the one to the right hand side. So
Yeah.
basically, it's
Ground level there.
yeah, the seabed. Yeah. So basically, it's a board hole into the limestone. You put your cage underneath that, and you pour your concrete into it, and then the socket need to carry on some meters up into the pile. And you see you got some rings inside the piles to act as shear connector to transfer from tube to concrete. Yeah.
The casing, is there a casing above ground that you terminate at ground level and then you direct bore below that? Is that right? We take the casing right down.
So you install the casing first. So I started with vibro hammer to go through sediment, then you hammer to go through the fracture limestone.
Yes.
Make sure you are maybe a couple of meters in solid limestone. Then the fly rigs come on top of the pile, go inside, and then core into it. So that's the picture here.
Yeah.
It's very small, but you can see the fly drill going inside the tube. But before doing that, after doing that, once you core, then you put the camera. You have to put some flocculant to make sure you settle a bit, otherwise you don't see anything, and then you put your downhole camera, check it's all good, and then reinforcement cage come in and trim concrete.
Second question online. Do we have time, Marty?
Yeah, you go. Yeah.
You spoke about strength requirements. What about durability? How did you ensure that?
For the pile or for
It's about the concrete.
concrete in general?
That's Brendon.
David jumped in on it as well, but the durability, so we use a lot of admixtures and things within our concrete mixes as well. So the same way you would batch it here in New Zealand, and we had quite a strict spec to work to as well. So like I say, Australian and New Zealand standards. I'm trying to think. We also put silane on the marine concrete.
Galvanized reinforcement.
Yeah, galvanized reinforcement. Yeah.
Corrosion admixture.
Yes.
Then the silane on top, but that was for the exposed concrete. The top concrete, the concrete underneath exposed to the splash. That was all imported from Indonesia to a much higher spec.
Yeah. So a lot of the wharf concrete was imported precast.
Right, so that's quite which do you hand over like a maintenance schedule?
Yeah.
Some training actually.
Yeah, we train the port operators on a lot of aspects of it, including like the diesel fuel station, how to use it and things like that, we hand over with operation maintenance manuals for all the aspects that need to be used and things like that, or maintenance over time. Whether how it will be maintained will be yet to be seen, but
Yeah, we've done the two aspects. We've done the theoretical aspects of the classroom things to understand what is asset maintenance. Try to keep it quite short because people fall asleep, obviously, and try to go to sites. And every time you guys were installing a new system or something like that, we make sure that the team of the port asset management they were setting up tag along to actually see what it looked like, to put things in power, etc. So they know how to deal with it.
even laying pavers, they came along to watch how we laid the pavers, so that if a paver broke, because that's why it is paved like that with all the small pavers, you drop a container, pavers smash, you can pop them out, chuck some new ones in.
We'll make sure they had a lot of spares as well as part of the project. So I don't know how many containers of
We lift a lot.
Yeah.
Final online question. Seeing the initial degradation, what considerations did you make of corrosion process or corrosion protection?
Yeah, so I think it's what I was explaining. So we use so Wolf number one, they use local material to do the concrete. It was a pour in situ, and the limestone, as Brendon explained, is super porous. It just sucked up straight away salt water, so it's pretty bad. So we make sure that we didn't use local aggregate for the soffit. We use a very high concrete mixed from Indonesia with 60 MPa. Put all the type of admixture, put some surface treatments, and have galvanized reinforcement.
The basalt aggregates, so anything in the splash zone was imported from Indonesia.
Any cathodic protection or otherwise for the casing?
Yeah, there was cathodic protection.
What did you use?
We use just a sacrificial anode because we consider using ICCP. But the problem in Tonga, the power is not reliable. They will have switched it off straight away. So we went for ICCP, sacrificial instead. We even considered go for hybrid at some point, but again, the price was a bit prohibitive. So what we did for the casing is fully painted. We got the CP system. We got a Denso shield as well on the tidal area. So we try to make it as robust as possible, basically. And we got some thickness corrosion allowance as well.
Yeah, I suppose you could say that behind the design of the whole thing was the idea that maintenance may be, maintenance may be patchy. There'll be a set and forget asset essentially. So yeah, a lot of precaution taken to protect it.
I had another one coming. Following the completion of piling works, were any seabed levelling operations undertaken? Additionally, were there any environmental constraints or challenges encountered during this phase?
No dredging at the time. We're doing a little bit of dredging off on one of the berths now, I think, coming up.
Maybe.
Yeah, maybe. But environmental constraints.
I can explain that actually. Because we built the wharf right at the drop-off of the reef, so you got naturally minus 12.5, which is actually a pretty good figure to get for the type of ship around. So we didn't have to do any leveling of some sort. But you can see every time you got some pile or even like the seawall, we put always the curtain around.
Yeah,
and we've done some pre-modeling as well, all this type of things. Yeah.
So yeah, in Tonga, it's kind of similar over here. They still have to get a permit before we can do the work, and there's certain controls we have to have in place. So we just work to best practice is what you'd work in New Zealand, and that did the trick. Yeah.
You mentioned the galvanised steel in this, but what cover, and did you use any treatment or concrete additive to assist with that?
So we use 75, which is the standard value for maritime engineering, I guess, or UK standard at least. And we put some corrosion inhibitor admixture, and we put some silane on top. So we went a bit double bagging, I guess. Yeah.
Awesome.
Cool.
Thanks, Brendon.
Thank you.
Thanks, Brendon. Very interesting. So we've got some food back there now. So we'll break for 20 minutes. Come back at 6:40. and we'll crack on with the next ones. So yeah, because we've got people at home down there too tuning in. But third presentation, one dear to my heart. One I've been working a long time with Worley's, and thanks Nelson and Pat for coming through with this presentation. But in a breakwater strengthening project, I could tell you a lot of things about it, but I'll leave that to Nelson Chiew from Worley, who is going to do that. So yeah, Nelson, crack on.
Thank you. Put that here, got my notes. Yeah, good evening, everyone. Thanks, Marty. Thanks, PIANC. Bit of introduction here. Nelson Chiew, Senior Project Engineer for Worley. Talk a bit about the wharf aid extension in a breakwater stage 2, where it fits in with the overall to-the-berth project. So on that, well, there's a bit of photos about bollard anchors, dredge, batter protection, team bar, fenders, and a little bit about QA, remote inspections that we've been doing. I think it's been going quite well. So partway through the project, hopefully it's going to be as good as it is at the moment. Just a bit on that heading, not quite there. So that should say twin berth project at the top. Overall, stage 1, wharf 7, which is number 2, that's been completed August 2023. With the next stage, which is stage 2, consent issued end of 2024, which consists of wharf aid extension, reclamation, and the breakwater repairs. There's quite a bit missing on there. On the right, what it's meant to say is key objectives for the twin berth project is future-proof Tairāwhiti region for generations to come. That involves getting 2 Handymax size vessels, a 185 and a 200 metre vessel to berth simultaneously. As part of that, we also, partway through, this is in a breakwater repairs, we've finished stage 1, partway through stage 2. What you can see there is the existing structure, concrete blocks, 1.8 metres wide, 2.8 long, and 1.5 metres high on either side. Rock fill in the middle. We were looking at about 4 blocks in height this end, and as we get out to the outer breakwater where it drops off, it's about 6 blocks high. The purpose of the repairs, you can see there's a few voids throughout the outer faces, same on the other side. What you can't really see through those photos is the cross-section, they're actually tipping out slightly. They're inclining out to between 5 to 10 degrees with nothing arresting them. Where this fits into the bigger picture, as well as to do the outer breakwater repairs, which I mentioned before, we need to get a crane travelling along out to the end to place the rock units for the outer breakwater. When we looked at it, we looked at a couple options. Option 1, which we ended up going for. We've got some vertical dowel bars coming through the centre of the blocks with a topping slab over the top. Option number 2, pretty similar, but we've got driven piles on either side of the blocks. And option number 3, a bit of both with a bit of a revetment. We ended up going with option 1, reasons being we could actually do everything land-based, didn't need any marine plant, maximises the use of the existing structure, which we thought was pretty great. Less impact to the environment and less impact to port operations. So the methodology that we had there, we wanted to stabilise the blocks, probably a bit exaggerated in terms of those block placement there, but essentially we wanted to fill the voids. We have some temporary works out on the side, pumping concrete in from the top. We drilled for the vertical shear anchors, so Dewey Day bars. We had them at different spacings depending on how bad the inclination was. Pin them, and then we actually use a Mateen bar capping slab, which I'll talk about in a bit more detail. Construction photos of the inner breakwater repairs. So down this way you can see the void repairs. Got some temporary works over the side, formwork, filled it with concrete, fill the larger voids. For the smaller voids, we actually put in grout socks through the drilled holes, which is on the top right, you can see there, and the capping slab, which is made with mateen bar tying in the vertical anchors on both sides. Which takes us through to twin berth light. So previously, Wharf 7, we had a restriction on ship sizes due to draft depth. The larger vessels would go into Wharf 8, which you can see just off the side of the screen there. Now that Wharf 8's been completed, they can take a 180 metre ship. With twin berth light, we'll be able to get 2 180 metre ships berthing simultaneously. Brief outline, you can see where that would be. And what we have shown on the screen there is 5 new bollards, 4 in the bollard trench, 1 for a short tension unit, 3 new fenders. We've got some localized dredging and batter protection as well as just a general concrete pavement over the top. The breakwater stability was quite interesting. We worked with Initia, completed an assessment of the existing breakwater. What we found that post dredging, there was a minor risk of destabilizing the breakwater. So there's a proposal of soil nails used to improve the stability of the breakwater by Initia, and I'll get to that as well very shortly. Missing a few headings there, but that should say bollard anchors. So a couple of the challenges that we faced on this project here were we had to get the breakwater repairs to be completed prior to mobilisation of the drilling equipment, and as well as the installation. So Richardson's Drilling, we worked quite closely with them on this project. We had some tolerances that they could achieve both in horizontal and the vertical angles on both planes, as well as the overall depth. On the right-hand side, you can see our 3D model. There's actually a few vertical pins missing, but what we ended up doing there was we could actually demonstrate the achievable angles that Richardson's could get, and with that as well, we were trying to demonstrate the theoretical tolerance between the raked anchors and the vertical dowels. The theoretical clearance that we've got on the screen is about 1 metre at the worst location. Again, theoretical, so we ended up having to be quite precise with the bollard anchors in there. They were positioned kind of within 1 to 2 degrees of each other, so 38 degrees in some, and in the horizontal, 39 degrees for others. It had to be quite precise to get clearance of 1 metre actually. And to achieve that in construction, photo of the bollard anchor sleeves, which is Civil did the design for this. You can see, I guess, the size of the excavation there, pin them in place. Photos from the 12th of September. So we've put in the grout pockets down the bottom now. We've actually put in quite a bit of the mateen bar in there as well. Now, on the top, that should say localized dredge batter protection. For this one, there was quite a bit of work that needed to go into the construction staging. It was quite critical to ensure that we didn't cut the whole face and then come back and do the saw nail detail. So that detail there is from Initia. Essentially, what we ended up coming up with in the methodology, cut it into small sections, maybe 3 saw nails across the page. At that point, they'll come back through, put in the saw nail, drill it out, install a mesh. So we had a mesh in there, as well as then installing the anchors. Once we did the anchors, grouted it up, tensioned it up, and then cut and repeat over the next stage. So we did that over the whole 16 metres. That's started in progress now. Hope all going well. Should be done reasonably soon. A team bar, so something I wanted to touch on, quite an interesting one. Local production in Gisborne, just across the river. Fibre reinforced plastic instead of steel reinforcing. Used it in certain areas, not in all. So the vertical dowels, which are just off the side of the screen, those are steel, whereas the slab itself was the team bar. Durability advantages, obviously, in the splash zone. Good benefit there. Probably the bigger benefit is ease of handling. These units here were literally manhandled from one end of the breakwater right up to the other end. A couple of people could pick them up, lift them in. However, a couple of things to note is that they come pre-bent from the factory. So there is a bit of a lead time. We need to get it right, and more specifically, unlike steel, if the bends are wrong, you can't bend them on site, which get your detailing right and it's fine, but as we find in other projects with steel, if you get it slightly wrong, you can chop it, you can bend it on site, etc. So you have to be pretty accurate, get your detailing right on it, but overall, I think it's a pretty good product, even better, made in Gisborne. Fenders, so we've got 3 new fenders that we put in place, precast and precast and cast in situ. The yellow section is the precast section. The plan is drill a couple dowel bars here, grout them in, drop the precast fender units over the top. Once the grout is set, we can then do the cast in situ section. Not that far in it yet. We're still in the precast section. We haven't actually put it in place, but all gone well. That's the theory. Oh, geez, we've gone through it quite quick. Lastly, this is meant to say QA and offsite inspections, probably a challenge that we have faced, which we've solved it pretty quick. Gisborne, we don't have an office in Gisborne, office in Taranaki. We do have an office in Wellington and Auckland. I myself based in Christchurch, and we've got our technical team sitting in Sydney. We did this for the Inner Breakwater Stage 1 project with virtual inspections. Mark completes most of the inspections on a Teams call, so we call up on Teams. He videos it, shares the screen, and records it, and we do spot checks. So we do that on probably every couple of days. Works really well, and due to the complexity of some of these projects, we've been doing a handful of them, 30% of the reinforcing placed, 80%, and then a final sweep. With that, with the PS4 certification, engineers based out of Taranaki, she dials into the meetings, and from there we've got a couple of site visits planned where she will go and inspect a couple of things. Obviously, to make a trip out to Gisborne costs a bit of money, so we're trying to time that with 2 or 3 pre-pour inspections all at once, rather than trying to fly there every couple of weeks and cost a bit of money. Before Q&A, I thought I'd just quick shout out to a couple of the people involved. So obviously Eastern Port, Initia, being the geotech consultants, Richie Civil, Richardson's Drilling, and In-Depth Diving. That's me. Got through that pretty quick.
Any questions? I think something that Nelson forgot.
Oh.
The Inner Breakwater was built in the 1880s, so it's bloody old, and it's done a good stint for us. But yeah, the team's done incredibly well, just strengthening such an old structure, sea protection structure, and used it in a really innovative way to be able to moor a vessel against what was a breakwater. It's not a wharf, right? Strengthening it and coming through with, applying some really interesting techniques to make it happen for us. But questions. I did see a hand there. Sorry, where did I see a hand? Do you want to into it? So, okay.
Yes. Can you talk a wee bit about the geotech conditions and also when you were sailing through the steel blocks, you had the tension that was down from locking them together?
So we shear only. So we didn't. We kept it within the blocks itself to act as a portal frame. Vertical dowels, L bars at the top, tied together. Didn't go into the seabed.
With the other bars you were using Marty, using some locations but not others. Just
shear, basically. Some 10 bar, pretty weak in shear. Good for tension / bending. Couldn't get them to work for the vertical anchors.
No. Cool. All right. Thanks, Nelson. Oh, we got one? No.
I was going to say, any questions, go to Mark.
Oh, right. Yeah. No. Cool. Awesome.
Yeah.
Thanks.
Cool.
Thanks, Nelson.
Thank you.
And so last presentation for the night is the importance of baseline data collection. Hopefully this works. No, disclaimer. So the importance of baseline data collection by Dan Govier from SLR here. He's going to talk us through this.
All right, kia ora koutou. Good evening, everyone, and welcome to SLR. I'm Dan Govier. I'm a technical director and a technical discipline manager here at SLR. I've been working in the offshore marine space around environmental monitoring and consenting for the last 23 years, right across the APAC region. So my experience spans oil and gas, aquaculture, ports and harbours, coastal activities, discharges. Give me a broad perspective on the challenges and opportunities that companies can face when developing marine infrastructure projects. So there's been a lot of changes over the last several years for developing projects in the marine space around regulatory regimes, the involvement of stakeholders, iwi, hapu, NGOs, and social licence to operate. However, one thing that's very clear from the projects that we've been involved in is that having a robust data set to inform your impact assessment or your assessment of environmental effects is very important. Today, I'm going to focus on how we set up these projects for success right from the start. And that's by getting your baseline right. Now, my talk's going to be a little bit different to what the three you've already heard. It's a little less infrastructure focused. We're probably right at the start of those projects in terms of setting it up and getting it in place. So before I start, I wouldn't be a good consultant if I didn't give our company a plug. So SLR, we're an environmental consulting company. We're founded in 1994. We've got more than 4,500 employees across 6 regions, 28 countries and 130 offices. We provide 45 different technical services across environmental, scientific and advisory disciplines and engineering. Here in Aotearoa, we've got 10 offices and just under 200 employees providing nationwide coverage. So robust baseline data, it's the foundation for any regulatory application in the marine infrastructure space and everything that follows as well. So to get regulatory approval, you need to understand the environment where your project is proposed and any potential effects that may arise from those activities. Our marine waters have a wide range of habitats, protected areas, sensitive environments, protected species and migratory pathways. So if your baseline data is poor or incomplete, the road ahead gets harder. Regulators don't like uncertainty, and uncertainty means more conditions, longer decision times and higher costs. So that's one of the very first steps in a large marine project is working out what we already know and what's missing. Using a service provider with experience is critical. Otherwise, you're spending time and money chasing questions that may have already been answered. The key is to identify the real gaps early decide what ones are worth filling, and you can't and shouldn't measure everything. There is already a lot of information known on our marine environment, but a lot of the available data may be old or collected for entirely different purposes. So you need to focus on what's most relevant to your project's risk, and what will give you the best value for your effort. When you build a solid data set across key environmental variables, you unlock a lot of benefits. You can predict and assess effects with confidence. You can design targeted and effective mitigation measures. You can even adapt the project itself to avoid those sensitivities. You can provide clear and credible information to inform your impact assessment. But most of all, you can build trust with iwi, hapu, regulators and stakeholders. So a robust baseline survey program usually begins with a desktop review, followed by targeted field surveys. The first step is a gap analysis. You need to understand what data already exists, what's missing, who owns it, and how reliable that data is. We also need to define the potential impact area of the project as well and the wider area of interest. Modelling can be a useful tool here to refine those boundaries. So where new surveys are required, it's important to capture seasonal variation, not just a single snapshot in time. Construction may span multiple seasons, so you need to be aware of what species or conditions may be present across that period. Some surveys may require regulatory approval as well, so you need to understand what's required before you commence and get into those early. Once the scope is confirmed, your approvals are secured, you can then implement a baseline survey program. For larger projects, an environmental monitoring plan is normally a requirement of the conditions as well. So this sets out the pre and post construction monitoring to measure disturbance and then your subsequent recovery as well. Now these photos are pretty cool. I took these many years ago. It's of the same reef, they're 6 months apart. So on the left, we've had sand inundation, and the reef was completely smothered in sand. It was unbelievable. 6 months later, on the right-hand side, it had all moved off again. So over that time, species abundance and species diversity had significantly changed, not because of human activities, but just because of natural coastal processes. So this is a state of the environment monitoring location for Taranaki Regional Council. It's also used as a control site for a number of coastal activities as well. But what these images do is they highlight the importance of having a control site in our monitoring programs, because it helps us distinguish between natural variability and project-related effects. So a good control site should represent a similar habitat to the I guess the environmental setting that you're undertaking your project in, but also be further enough away that it doesn't get impacted from your project. Without that baseline comparison, it's easy to misinterpret natural change as an impact, and that can have a big impact or a big consequence on compliance monitoring and management decisions as well. So there's a range of methodologies we use to collect physical and biological data during baseline surveys. I won't cover them all tonight due to the time, but what I did want to highlight is one methodology we use here. So this is called BRUVs, or Baited Remote Underwater Video Surveys. So these are highly effective for identifying fish species, and they provide compelling visual evidence of what is present in an area and how that may change over time. So here's an example of a project we're involved with, and it's pretty cool seeing snapper in their natural environment. So from a science perspective, we use these videos to measure and compare fish numbers over time. But beyond the science, what they're also good for is they're a fantastic tool for sharing with consultation. So it makes the data real and relatable for people as well. So yeah, it's awesome. I could look at this all day, but we'll have to carry on, sorry. So I've seen projects where early thorough baseline survey work made applications process much faster and with fewer issues as well. By contrast, where there's gaps in the data and there's potential uncertainty, regulators need more information, causing delays for your program. So front loading your application is very important, especially for fast track applications. So you only get one shot at it in most cases, so you want to put your best foot forward, reduce the uncertainty and requirements for additional information requests. Now, what I'm going to do is I'm going to run through a couple of project examples that we've been involved with and highlight the importance of having a robust and detailed baseline data set. So one of our clients held petroleum exploration permit down in the Great South Basin. Seismic surveys have been conducted. A number of areas have been identified as having potential accumulations of gas. The only way to confirm is to drill an exploration well, and if successful, then undertake further appraisal drilling to determine if there's commercial potential for that well or not. So we prepared a marine discharge consent application for our client to undertake a 10-well exploration and appraisal drilling program. The two priority wells are the red dot and the yellow dot there. The permit area is the red and the blue, the blue polygon. What we did is we determined an area of interest. So that's our red polygon on there. So the area of interest that needs to capture all of your activities that are proposed under that consent, but also the effects from those activities. So in this case, with drilling, there's the discharge of drilling muds, drilling cuttings. So we needed to incorporate that across the entire 10-well project that they wanted to do. So because this area was relatively unknown in terms of the habitats that were present, it was a long way offshore and the species that were present, it left gaps in our regulatory application, and that would result in uncertainty. So that uncertainty had the potential to make the regulatory process difficult for ourselves and our client. So what we did is we proposed an extensive baseline survey within that area of interest so that we could understand the existing environment, and then that information we would use to inform our consent application. So the survey was very extensive. It was conducted with NIWA on board the Tongaroa. We combined a regional survey right across the area of interest with a pre-drill survey which was specific to that one first exploration well that they wanted to drill. We collected a data set that took into account the physical, chemical and biological properties of the area, and we also captured a lot of video imagery as well. Having a robust data set, it allowed us to understand the existing environment and understand the sensitivities and inform our environmental risk assessment with the best available data that we could get. That information that was shared with stakeholders and utilised as part of management decisions, as well as the development of our mitigation measures for the project. So as part of the baseline survey, we found 3 sensitive environments and 1 protected species within that area. It was considered that these habitats and species were rare around New Zealand, but our data set showed they were actually widespread right throughout the whole area of interest. Sensitive environment is defined in this instance under the EEZ Act, the permitted activity regulations, is an area based on either density or spatial coverage of a particular species or habitat which exceeds specified ecological thresholds. We did 73 video transects through the area. Each transect was an hour long. And xenophyrophores were present in 55 of those transects. Now, xenophyrophores, they're large, single-cell organisms. They live on deep water habitat, generally on flat, muddy seabed. And what they do is they form fragile habitat. They form these structures which just keep building. And what that does is it creates habitat for other species. And that's the importance of them down there. So of those transects, 11 of them trigger the threshold for a sensitive environment. And under the regulations, you can't impact or damage those. The rest of the transects, they had those species present, but they weren't present above that threshold. So having a robust data set changed the conversation that we had with the regulators. It was based on the most up-to-date information. We're able to model, with the information that we had, the distribution of sensitive environments across that area of interest, and through expert conferencing, we determined a 5% threshold for disturbance of sensitive environments. And that would then achieve a 95% protection of those sensitive environments. Had the data set not been so extensive, I feel the outcome may have been very, very different in terms of the successful decision our client achieved. So the reason those species, a little bit of background to it, the reason those species were defined as a protected species or sensitive environment is very little work's been done out on the deep ocean. A lot of the work and a lot of the information we know has been done by NIWA as conducted by government funding. They do lots of video survey work, but they don't analyse anything underneath 50 millimetres in size. So even though they're there and they're on the information, they don't get counted because they aren't paid to go down to that level of detail. Because it was for a project, we wanted everything analysed. They went below 50 millimetres, and then what a species was considered to be sensitive was actually very widespread. We did another project the next year in the Canterbury Basin, further north of Canterbury, same thing. They were all through there. So it's very information, but it all comes down to user pace, and I'm sure many of you are all well aware of that as well. So I guess basically what that does is it emphasises the importance of front-loading an application. So not trying to do additional work by way of conditions, doing it up front, and that with a fast-track application in particular, you might only get one shot at it. Right, second project, Port Taranaki dredging program, and thanks to Ludo for letting us talk about this. This is a very special project for me. I've been involved in this project since 2002 when I worked at Taranaki Regional Council. And now 23 years later, SLR Consulting was supporting Port Taranaki with the reconsenting of this dredging program. So it's really cool to be involved in. So Port Taranaki, they hold consents for capital and maintenance dredging within the port. Sand accumulates around the tip of the main breakwater and within the port and requires dredging to maintain safe navigable channel for the large ships to enter and leave. So there are two consented disposal sites. There's an offshore and an inshore site, which you can see on the bottom left there. These consents will expire in 2029. However, Port Taranaki have been very proactive and they've started that reconsenting early, and the intention is to have consents in place by 2026. So the inshore disposal area. So what happens, and the reason this happens and the dredging is required, so the natural littoral drift off the Taranaki coast is to the north. Sand comes down off the rivers, off Mount Taranaki, comes down the rivers with the littoral drift and with the littoral system. It moves north and it accumulates on the tip of the main breakwater because that interrupts and traps the sand, particularly around that main breakwater, and it folds in, and then as the waves come, it just acts as a big sink and requires dredging. So the nearshore disposal site, many years ago, it was introduced to dispose fine, clean, coarse sand from the tip of that main breakwater back into the nearshore system to then re-nourish the beaches to the north of the port. There's limits on the volume of sand that can be placed in there to ensure the area is not overloaded. Extensive modelling and dispersal modelling was done to calculate the limits that could be placed, where it could be placed to have that effect to re-nourish the beaches. There was lots of concerns about this initially when it was first proposed. Those concerns were around the potential for sand to smother intertidal and subtidal reefs. These reefs are very important. They're regularly used by local hapu and the wider community as well for collecting kaimoana. So that's where all the concerns came around. So back in 2002, I developed a very extensive monitoring program to assess intertidal and subtidal reefs, as well as the establishment of a kaimoana monitoring program. So that photo on the bottom right is me. We went out with the local hapu to start with to develop and find where we would do these sites and put a methodology in place. And these monitoring programs are still going now. So I started these in 2002 and they're still going each year. They were going every quarter when we started for the first 4 years to capture that seasonal data. But there's such an awesome long-term series of data. So pretty cool photos there. This we're going to talk about this shortly. So the other photos are in relation to a recent survey we did earlier this year with our team, having fun out there on the water. It's a pretty special place, especially when the weather's good. It's like Wellington on a good day. You can't beat it. Very few days where it's that calm, but you picked a great window and it was pretty awesome. So as part of the reconsenting process, cool. No, that's right, yes. So as part of the reconsenting process, we recommended that environmental surveys should be conducted to understand the current existing environment. So the most up-to-date information was available to inform the application. So dredging has taken place for many years around this region. We wanted to understand the current state of the seabed, both within and down current of these disposal areas. So on the left-hand side there, there's 19 stations. There are benthic grab stations. So we took grab samples at each of those. We looked at the physical, the chemical, and the biological properties of the sediment. On the right-hand side, we undertook a drop camera survey. So there's 407 stations there. We got high-resolution imagery at each of those stations. And a number of those stations are the same that we used back in the very early survey work that was conducted in 2000. So again, we've got that huge time series of data. And what that does is it allows for comparisons of change over time for the different habitats that are present. So on the inshore ground, you can see on the left-hand side there, there's that funny little kink out of it on the inshore boundary. The reasons it's there is the initial baseline survey had identified a big kelp forest through there. So The disposal area, that was the best area to dispose of the sand for it to feed north, but they didn't want to smother the kelp forest, so they cut it out, and we'll show you some results next on what's there. So our drop camera results, on the left-hand side there's all the locations. So what we did is each image that we got, we analysed it, we just prescribed it a different habitat type for what was there, and then we also observed if there was any species present as well. So there's different colours which relate to the different habitat types. So if you can see it, the offshore, the outer colours which are more tan, that's sand. The pink areas are your coralline pavements, cobble reefs. The light green are your kelp forests, and then the dark green is the mixed algal, mixed kelp forests as well. So on the right-hand side, there's some of the representative images of the different types of habitat, the kelp, the platform, of course, the sand on the bottom, mixed algal forest in the middle right, and then you've got some sponges on the top there. That's our camera system on the bottom there. Basically, it goes over, we've got a live feed, you can see down there's a quadrat, so that's a known area. So then we can work out calculations of area as well. So the importance of having a time series of data can never be forgotten, particularly when it comes to reconsenting. So Port Taranaki has got a data set which goes back to 2000 now, and it enables us to assess change over time. And it shows how the industry and the natural marine environment can coexist when done right and based on the best available information as well. So that kelp forest on the left-hand side, you can see there's actually been an increase in kelp. So that's a really cool story for the port and the local community, that based on the science and the modelling that's been done and the monitoring to assess that, it hasn't killed the reefs, it hasn't smothered the reefs. There's still a natural, healthy marine system there. So the other good thing is doing these surveys, Port Taranaki, they were great. They provided the vessels to undertake the survey work. And on the right-hand side there, that's the tug that we did our grab sampling off. It's a family affair. That's my brother on the sticks. He's a tug master at Port Taranaki, so it was pretty cool having my brother out there driving my team out doing the monitoring. So that was pretty cool as well. Right, now, Port Taranaki, they're proposing to combine these disposal grounds. So what that does is it's going to enable dredge material to be disposed of a much larger area and to avoid any, I guess, lumping that can happen in that offshore area. So dispersal modelling and environmental surveys, they've been crucial to informing this decision-making process of how that's going to work going forward for the consent application for this revised disposal area. The proposed area has been shared with stakeholders and the local iwi and hapu, and it's informed and backed up by robust data as well. So going forward, what's proposed is adaptive management, and that's going to be used to manage the disposal areas. So a dredge management plan will be put in place. That will be informed by multi-beam surveys prior to each dredging campaign, which will then assess where the sand is and where's best to deposit the dredge to spoil. So a few considerations here. Baseline surveys take time. You can't shortcut a year's worth of seasonal data, so you need to start early. Think about seasonality, weather, vessel availability. Make sure you've got a team with the capacity to handle the fieldwork, the data analysis, and the reporting as well to meet those timeframes. And engage specialists early, so your surveys are strategically aligned to your project and not just for more science. And finally, relationships matter. Keep building those with iwi, with hapu, stakeholders, because they're critical as your projects move forward. And so basically to close with, so if you start with strong baseline data, you lower your risk, you reduce your uncertainty, you speed up the consenting process, and ultimately you deliver better projects. Just as important, being seen to gather robust data builds trust with iwi, with hapu, with stakeholders and NGOs, because it shows you understand the environment that you're working in. And don't reinvent the wheel. Use service providers with experience and knowledge of your marine environment. It will save you time and it will give you the answers that you need. And start early. These projects and surveys, they'll always take longer than you expect. If you ask me when to begin a baseline survey, I'd say the best time was yesterday, the next best time is today. So Thanks very much for listening. Glad you all stayed on. Thanks for your time and happy to answer any questions. Right, good.
Like it's not overly technical, it's just about job camera images. So that frame, is that just for scale?
Yeah, it is. So you know the known area is normally 0.25 square metres, and then you can scale it up to work out a coverage, or within that how much coverage it is of kelp, or just so it's a consistent metric that you can measure going forward for how much coverage in an area, or how much sand over the reef, etc. Yes.
Another question, Dan. I could watch that video all day as well.
Yeah.
I'm keen to understand the use of it, because I guess there's the deep scientific data that you can collect, as well as that type of data as well, which is scientific but fantastic in terms of stakeholder.
It's used as a, obviously there's a science element to it. Where that project first came into play was a request from iwi as part of understanding what effects offshore activities were having on the marine environment, and basically the species of concern and what's out there. And it's a way of doing it without going underwater. It's repeatable. You can get iwi involved. You can take them out on the vessel. You can help them to deploy it, get them involved, and then they can basically see and monitor those results. It will change. The seasonality components there as well. Water temperature makes a huge difference on the distribution of fish. So you need to obviously think about that, and, consistency with your seasons. But the results we've done and we've shared as part of consultation and taken it back to iwi and Hapu, they've loved it. It's been really powerful just knowing what's out there and the different types of species.
Thanks, Dan.
Thanks, Marty.
Thanks for that one, mate. Yeah. Oh, yeah. Thanks, everyone. Thanks for coming along. That wraps us up. But yeah, if you're interested in PIANC and you're not a member, do go on our website and have a scout around and join up. Get your boss to shout you a corporate membership or whatever it is. But if you're not,